And it's finally here, 2-5, day 4, the end of section 2-5. This video is more anticipated than the Avengers Endgame, and let's dive right in with this warm-up. We've got in blue f of x is this function, and we're going to evaluate f of negative x. Now, when the negative goes in, if the exponent is even, that negative will just get eaten up. It'll get squared away. If the exponent is odd, a negative will escape an odd exponent. So to evaluate f of negative x, well, this x to the fourth, the even exponent will eat up the negative one, so that just stays an x to the fourth. This x cubed, an odd number of times you multiply a negative will escape, so that'll change this sign to a plus. We have another even exponent, x squared. That will square the negative away. It does nothing. Here, that is just going to come down and change that to a minus. Because we're making this x, we're replacing that with a negative x, so that'll come down and change it to a plus. So if you got an odd exponent, you get a sign change. If it's even, you leave the sign alone because the negative's not doing anything. All right, there's some other tests for the zeros of polynomials to make our guessing and checking a little easier. It says you know that an nth degree polynomial function can have at most n real zeros. Of course, many nth degree polynomials do not have that many real zeros. For example, x squared plus 1, that has no real zeros. X cubed plus 1 has only one real zero. The theorem below, called Descartes' rule of signs, uses variations in signs in order to analyze the number of real zeros of a polynomial. A variation in sign means that two consecutive non-zero coefficients have opposite signs. They will switch. And here is the rule of signs. First, they define the polynomial, some number x to the n, some other number x to 1 power lower, ... all the way down to x squared, x to the first, and a constant. That's a polynomial with real coefficients, and your constant at the end is not 0. The number of positive real zeros of our function is equal to the number of variations in sign of the original function, or less than that by even. So if we figure out there were 5 sign changes, subtract 2, that would be or 3, subtract 2 more, or 1. 5 or 3 or 1 real zeros. The number of negative real zeros of our function is equal to the number of variations in the sign of f of negative x, or less than that number by an even integer. So let's say we go through and find that one, and it's, let's say we find there are 4 possible negative real zeros. Well, if it's 4, it could be 2 or it could be 0. We keep subtracting 2 from each possibility. And it says below, when using this rule of signs, count a 0 of multiplicity k as k zeros. For example, x cubed minus 3x plus 2 has 2 variations in sign, so it either has 2 positive or no positive real solutions. Okay. Example 10 here. Let's see. First, let's figure out the possibilities that we have. At the end, factors of 4, plus or minus 1, plus or minus 2, plus or minus 4. Leading coefficient is 3, so that's plus or minus 1, plus or minus 3. Oh, now hold on. I'm getting a little ahead of myself. If we read the directions, determine the possible number of positive and the possible number of negative real zeros. So let's see. Of course, this 3x cubed at the beginning is positive. We've got our x squared. We've got an x. We got a constant. So the positive real zeros, let's count the sign changes. Positive to negative, there's 1. Negative to positive, there's 2. Positive to negative, there's 3. So it could be 3 or it could be 1. Subtract 2 from it. Let's determine our possible negative real zeros, f of negative x. So again, this is why we had the warm-up, and we had that just in the theorem box a little bit ago. This 3x cubed, odd exponent, that's going to change it from a plus 3 to a minus 3. Even exponent, nothing changes, minus 5x squared. Odd exponent, sign's going to change to a minus. No variable at all, that's going to stay a minus. So let's see here. Negative to negative to negative to negative. 0, negative, real zeros. So, as I was going through and figuring out all these plus and minus numbers, plus or minus 2, plus or minus 1, based on this, we could not check any of the negative. Just only start checking the positive ones with synthetic division. Try this one. Determine the possible number of positive and negative real zeros. So pause the video and answer the question. So possible, positive, real zeros. So we go from positive to positive, no sign change, still positive, no sign change, still positive, no sign change. There are none. There are no positive real zeros. So if we're to start checking, we'll start with the negatives. Let's do f of negative x. So blue ink, first one is 2x cubed. That sign will change. The 5x squared, it's even exponent, it's going to stay the same. X to the first will change to a minus x to the first, and the plus 8 will stay a plus 8. So now we have our possible negative real zeros. See, we're starting at negative to positive. There's one sign change. There's two sign changes. There's three sign changes. So it has either 3 or it has 1. It's not going to have 2. It's not going to have 0. And those are our negative solutions. Another test for the zeros of a polynomial function is related to the sign patterns in the last row of your synthetic division array. This test can give you an upper or a lower bound for the real zeros of the function. A real number c is an upper bound for the real zeros of our function when no zeros are greater than that. So if we do this test on, let's say we have possibilities 1, 3, and 5. If we evaluate 1 with synthetic division and we figure out it's an upper bound, we know the real answer is going to be less than our upper bound. So we would not bother checking 3 or 5 because they're above 1. Similarly, c is a lower bound when no real zeros of the function are less than c. So here in our box, the official definition, upper and lower bounds. F of x is a polynomial with real coefficients, positive leading coefficient. We divide our function by some factor, x minus c, with synthetic division. If c is positive, and each number in the last row is either positive or 0, then that c value is an upper bound. The real answers are going to be lower than that number. If c is negative and the numbers in the last row alternate positive to negative, 0 entries count as either, then that number c is a lower bound. And we would not want to check any other possibilities lower than that. We'd want to check the ones above. So here, as we're guessing and checking, we can figure out if we're kind of on the right path using these upper and lower bounds. So let's see for this one, number 11. And this one, let's list them all out. So numerator, factors of 2, plus minus 1, plus minus 2. Leading coefficient is 6, plus or minus 1, 2, 3, and 6. So if we write them out, 1 over 1 is 1. 1 over 2 is 1 half. 1 over 3 is 1/3. 1 over 6 is 1/6. Now let's do 2. 2 over 1 is 2. 2 over 2 is 1. We already have that. 2 over 3 is 2/3. That's a new one. And then 2 over 6 is 1/3. We already have that one. So let me even write it like this. I'm going to write them in increasing order here. Let's see. 1/6, 1/3, 1 half, 2/3, 1 and 2. 1 and 2. So there they are in increasing order. And I could do the negatives like this. -2, -1, -2/3, -1/2, -1/3, -1/6. So those are all of our possibilities that could be out there. So let's see. Let's do our sign check. We're at positive to negative. There's the sign change. We've got another sign change and a third sign change. So our positive possible real zeros are 3 or 1. Oops. There we go. Let's do our f of negative x. So the first one, it's an odd exponent. Sign will change to a minus. Even exponent, that minus 4x squared stays. The 3x will change to a minus 3x and then the minus 2. So here we have no sign changes. Negative to negative to negative to negative, no sign changes. So that means, oops, for the negative possibilities, there are none. Negative zeros, none. So down here to my list, I can scribble out all my negatives. We're not going to waste 1 second checking those with synthetic division because we know they're not going to work. So here's our solutions. Oop, and I back up. It says here for positive, we're going to have 3 or 1. And this is a third degree, so they're either all going to be positive, or we're going to have one real one and the others will be imaginary. So let's do a little synthetic division, and let's start with 1. I'm going to move this up here. This is our list of suspects. We're going to start with positive 1, and we're going to synthetically divide that into 6 minus 4 plus 3 minus 2. So we bring down our 6. 1 times 6 is 6. We add that and get a 2. 1 times 2 is 2. We add that and get a 5. 1 times 5 is 5, and that becomes a 3. Now we do have a remainder, so 1 is not a factor. But look at our answer row. Positive 6, positive 2, positive 5, positive 3. We found an upper bound. 1 is our upper bound. So our real answer is below 1. So we can now eliminate 2. We're not going to check 2 because we know it's not going to work right now because we found our upper bound. Let me get rid of this. And let's try another number. Let's try -1 and see what happens. -1. And we bring down the 6. -1 times 6 is minus 6, and that's a minus 10. -1 times -10 is 10, and that column adds to 13. -1 times that is minus 13, and we get a -15. Now look at our signs. Positive to negative to positive, and then back to negative. So it alternated perfectly. What we found here is negative, well, oh shoot, why did we even check -1? We know that we've already eliminated all our negatives. But this does prove that -1 is a lower bound. This would happen if we check any of our negatives. You know, we'd always get this alternating signs, so we know we're going to be above -1. So let's just try a nice fraction to work with. Ooh, I shouldn't have erased all that. Would be positive 1/2. Let's get rid of this. And let's try positive 1/2. 1/2, bring down the 6. Half of 6 is 3. Add that, you get a -1. Half a -1 is -1. 3 minus 1/2 is 2.5, or that would be 5/2. Oops, I was looking at the wrong spot on my notes. We don't want that. Let's do 2/3. We know that 1 is an upper bound, so let's move down to 2/3. 6 times 2/3, that would be 2 over 3 times 6 over 1, multiply straight across. 12 over 3 is 4. -4 plus 4 is 0. 0 times 2/3 is 0. Add that and we'll get a 3. 2/3 times 3 is 2/3 times 3 over 1. That's 6 over 3, or 2, and there's our 0 remainder. All right, so let's see. That was a 6. We started with a cube, and we factored out a factor, so this is 6x squared plus 0x plus 3. Ooh. Now it does say find all the real zeros. I think we've found all the real zeros. Let's just check this real quick. So what did we factor out of there? 2/3. So if we factored out a 2/3, we know there's an x minus 2/3 is one of our factors. So if we set that equal to 0, we get x is 2/3. That's one of our zeros. Let's do it with this one. 6x squared plus 3 is equal to 0. Let's subtract 3. 6x squared equals negative 3. And when we divide, 3 over 6 will be 1/2. Negative 1/2. And if we square root both sides, we're going to have an imaginary, so it's not real, and the directions asked us for the real zeros. So it looks like 2/3 is the only one, and the book's graph will back us up on that one. Okay, here, find all the real zeros of this one. Yeah, I'll just leave you on that one because you can do your signs. You'll see how many positives and negatives there are. We can and whittle it down. And you know, in the last example, when I started synthetically dividing by a fraction, I was looking down at this problem, so that might be a fraction you want to check out. Pause the video, find the real zeros, start it back up for the thrilling conclusion. Okay, looking at this, we have 1 sign change, 2 sign change, 3 sign change. So there's either 3 or 1 positive zeros. If I run a negative x through there, this odd one will change signs. This x to the first will change signs, and now they're all negative. So there are 0 negative solutions. So all our solutions are going to be positive. So let's see, that's the factors of 3. 3 and 1 are the numerator terms. Denominator are the factors of 8. 1, 2, 4, and 8. So let's see, we have 3 over 1, 3 over 2, 3 over 4, 3 over 8, 1 over 1, that's 1, 1 over 2, 1 over 4, 1 over 8. Again, there is no plus minus because we know all the roots are positive. If you try 1, if you synthetically divide 1, there will be all positives in the answer row, so 1 is the upper bound. And all that does is eliminate 3 and 3/2. If you try, well, we already know that we could try the smallest of all the negatives, or I mean all the positives, and that would show us that it'd be a lower bound. Well, I did sort of spoil the surprise in example 11. Let's try 1/2. 1/2. 1/2, synthetically divide into 8 minus 4 plus 6 minus 3. Bring down our 8. Half of 8 is 4, and that adds to nothing. Half of nothing is nothing. Add that and get a 6. Half of 6 is 3. There's our 0 remainder. So x equals 1/2 is one of our solutions. And this will be 8x squared plus 0x plus 6 is equal to nothing. And there's minus 6. So we're going to subtract 6. It's over here and it's a negative 6. And then we're going to divide by 8. Negative 6/8, that could reduce down to 3/4. And if we square root both sides, we hit imaginary land because we are square rooting a negative. I believe the directions were for the real zeros. So we found the real zero. X is 1/2. And I think that's the end. yeah, we're going to skip this example 12 and add huddle. Just a little summarize on there, nothing big. It's in your book and on the ebook. Check WebAssign for the assignment.